Hey there, Chem 112. It's Virginia here to go through PracticeFinal C. Disregard the 4. This is the third practice exam for the final. So, the first question asks what the electron configuration of iron in this iron cyanide complex is. So we know that cyanide exists as Cn-, and we have 6 of those cyanides. So those are overall contributing a -6 to this complex. And since the charge is overall -3 on the entire complex, the iron must be +3. And that's really important for when we figure out how many electrons it has and where those electrons are. So whenever I have an ion that I have to write the configuration for, I start by writing the neutral elements configuration. So for iron, we'll start with the argon core, 4s, and then our 5, 3d orbitals. So after the argon core, iron has 12 electrons, or I'm sorry, not 12, 8 electrons to fill in. 8 electrons. So I'm going to draw 8 arrows, and I'm going to start by filling into the 4s. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the neutral iron. If we want to make it 3+ now, we know we have to lose 3 electrons. And so we're going to erase some of these. And the ones that we're going to erase first are these 4s electrons. So we'll lose one 4s, we'll lose the next 4s, and then we'll remove this paired 3d electron. So then the configuration for our iron overall, our iron ion overall, is going to be this argon core, 4s0. So sometimes we just don't write that in, but here in the answer choices they have included it. And then 3d5. Making the answer choice here B correct. So here in question 2, they ask which solids would be classified as network covalent solids. And so network covalent solids are going to be where they have the structure that kind of connects the layers above and below with each other. So you can imagine this is a diamond. All the atoms are interlaced and interconnected. That's one of the reasons why they're so strong. And generally, I look for metalloids to make these kinds of solids. So I look for metalloids and then also carbon structures. And there's a great table in the notes that really helps delineate some of the different types of solids. Then we would say water is just going to form a molecular solid because it's just a molecule. And these buckyballs will also just form a molecular solid where we have like a bag of soccer balls kind of making up that solid. And this iron sulfide will be ionic because we have a metal and a nonmetal forming a salt structure. Okay, so the answer here is D. And I would take a look at the table in the notes because it really is helpful. For number 3, they're asking for which reactions Kc is equal to Kp. So these are both just equilibrium constants where we've used different units to calculate them. And so to switch between them, we have this equation that where Kp is equal to Kc times RT to the power of delta N. And delta N is going to be the moles of gas from the products minus reactants. And for these two numbers to be equal, we need this entire term to be equal to 1. And if delta N is equal to 0, we can guarantee that that would be the case. So I'm going to go through and figure out the delta N for each reaction. So in the first one we have 1, 3, so 4 moles of gas in the reactants, and we go down to 2 moles of gas in the, or 0 moles of gas in the product. So we have to be really careful with looking at our phases. So this would have a delta N of -4, go from 4 to 0. And on the left we have 1, 2, so 3 moles of gas, becoming 5 moles of gas. So this is going to be a +2. We go from 3 to 5 moles of gas. In C, we have 2 moles of gas, becoming 2 moles of gas. So our delta N is 0 here. In D, we have 2 moles of gas, and we make a total of 5 moles of gas, so this would be +3. And in E, we have 3 moles of gas, becoming 1 mole of gas, so this would be a -2 delta N. And so the answer choice here would be C. One more thing I want to say about using this equation. We didn't have to do it here, but if you do need to use the R value, it's the only time we use the other R value, the 0.08206 liters ATM Kelvin mole. Okay, this is the only time we use a different one. Okay, for number 4, they're asking which of the following solids would have the highest melting point. And so whenever I have a question like this, or they want highest melting point, I look for which solid is ionic. Because those ion-ion interactions are really strong and really hard to break apart. You'd have to put in a ton of heat to separate them up. And so the only ionic solid we have here would be the sodium chloride. And this probably makes sense. I don't know if you've ever seen your table salt just become gas in front of you or liquid in front of you. And then of course we usually see ethanol as a liquid, which suggests it melts pretty easily. Argon we usually see as a gas, which suggests it melts pretty easily. Mercury we usually see as a liquid. And water, you know, we see it all kinds of ways, but we know it's going to melt before sodium chloride does. So the answer choice here is B. In number 5, they're asking which of the following images represents a bonding molecular orbital. And so we know bonding molecular orbitals are where the electron density is able to overlap, whereas antibonding orbitals will have nodes. And we represent these nodes usually in these pictures as dotted lines. And so we can easily see, boom, antibonding, boom, antibonding, boom, antibonding, which leaves 3 and 4. Okay, sorry, I yelled at my roommates. So now you can see the electron density overlapping here, because really what we have are 2 kind of p orbitals coming together there. And then here you can see the overlap in this position. So 3 and 4 are the correct answer.